All right, today we're talking about graphing sine and cosine again, but now we're going to add in what's called period changes, which is kind of like the frequency of how often our sine and cosine wave cycle. And then our phase shift, which is essentially a horizontal shift. It's really just shifting left and right. We call that a phase shift on these particular types of graphs. Okay, so I alluded to this a little bit last time in our video, that this is the full way we can manipulate sine and cosine by changing values of A, B, C, and K. And we talked last time about A being our amplitude, right? Specifically, the absolute value of A. Oops, that is the wrong. The absolute value of A is our amplitude. But now we're adding in some new stuff. So we're going to write down the formula, and I'm going to explain what a period is in a second here. But to find the period, that is the standard period or cycle for sine and cosine, as 2 pi divided by the absolute value of B. So here's a graph of one cycle of sine, right? And what we're talking about, remember we talked about the height kind of from the center to the top or bottom was called the amplitude. So that would be 1 unit. And now we're talking about the time it takes to go through one full cycle before sine would begin to repeat, right, is called the period. So in this case, the length from here to here is called the period. And for sine and cosine, its natural period is 1 full unit circle, 2 pi. Right? We can see that from, there's my cosine graph. Same thing to go from cliff to cliff and begin to repeat itself is 2 pi. So if we want to change that period, we're going to change the variable b. Okay, so by changing b, we can change how often it repeats. Maybe we want it to repeat every pi units or pi over 2 and make it much more frequent. Or maybe we want it to repeat every 4 pi, etc., and make it less frequent and more of a stretched out horizontally. So by changing b, we're going to be able to stretch and compress horizontally, which is the first time I think we've done that. Okay, we also have what's called the phase shift, and essentially this is just our horizontal shift. And to find which direction you've shifted your graph, you essentially take this equation, bx plus c, and set it equal to 0. And if you were to solve for x by subtracting c and dividing by b, right, we arrive at our formula here, the opposite of c over b. So it's essentially just setting the inside equal to 0 and solving for x or theta or whatever variable they put in there. Okay, that's called our phase shift, and that will tell us if we've shifted left or right. By doing the opposite of c over b, that sign is going to tell me if this value comes out negative, we've shifted left. If it's positive, we shift right. Okay, and then of course the vertical shift we've just kept as k, since, with h and k we've used in the past. Here, to find the h value, we're essentially using this formula. Okay, but h and k are horizontal and vertical shift. It's just called the phase shift for sine and cosine graph in most trig function. Okay, so here are some important steps. So you want to take a second to write these down because we're going to need these when we have all these complicated versions of a sine and cosine graph. So I found this to be the easiest over the years. We're going to start by identifying the vertical shift, our k value, and mark that like it's our new x-axis. So we're going to essentially shift our graph up or down k units. Okay, and kind of mark that as the center of my graph. Step 2 is find the amplitude, which is always the absolute value of a. Remember, amplitude is a distance, so it should always be positive. And we're going to go up or down that many units to mark the maximum and minimum with dashed lines, kind of to remind ourselves to stay in between the lines. Like if our amplitude is 1, we'd put these lines in to stay between +1 and -1. It can only go up or down 1 from the center. Then we're going to find the period by calculating 2 pi over the absolute value of b. And we're going to mark the start and end of one period. So we'll kind of put little marks on our dash, start and end. Then we'll make 5 equally spaced marks if we don't have our own graph to work with, or a graph with a scale already provided. And we're going to graph in our sine and cosine graph. Okay, but we're going to use a dashed line if there is a phase shift. So because it won't be our final graph, we'll kind of put in a dashed cosine or sine wave. And then we're going to use our phase shift and move all of our points left or right to find our final graph. So left or right from this dashed graph, kind of shifting it left and right to find our final graph. Okay, I know that's a lot to remember, but take a second, write these down before you continue. All right, so I put the steps up here at the top again, just for reference. You don't need to rewrite them again, but so it's easy to reference as we work through the first example here. Okay, so it's asking me to graph y equals the sine of 2x plus pi over 2. So let's go through first and just identify a, b, c, and k. So my a value here is just a 1 in front of our sine. It's our multiplier. Our b value is the multiplier on x, which is positive 2. Our c value is positive pi over 2, since it was plus pi over 2. And our k value out here you could think of as plus 0. There's nothing being added or subtracted, so no vertical shift. Okay, so let's write in some of these values, our calculations here. Our first step is to identify the vertical shift, okay, which is 0, and mark that as our new x-axis. Well, since we don't need to shift up or down, the x-axis is our new x-axis. We didn't go up or down at all. Okay, next, find the amplitude, the absolute value of a. So the absolute value of 1, of course, is just 1. And it says go ahead and mark the top and bottom with dashed lines, just to remind ourselves to kind of stay in between them. So we dash in lines like these. Okay, so dash lines, we went up and down here 1 unit. So I'm using my scale as each box is 1. To give ourselves some maximum minimums to kind of stay in between. Okay, then it says find the period. 2 pi divided by the absolute value of b. 2 pi over the absolute value of b, where b is 2. So we're essentially taking the normal period of pi and 2 pi and dividing it by the absolute value of b. So doing the absolute value, of course, the bottom becomes positive 2, and simplifying, we get pi. Okay, so it's going to repeat every pi units. So what we're going to do is mark the beginning and end of pi. So we're going to go from 0 to pi. So within that distance, we're going to get one full sine wave, like sand to cliff to sand underwater, sand. Okay, and what we normally do is mark 5 equally spaced marks, okay, between the start and end here. So we'd go halfway between 0 and pi, which would be here at pi over 2, and then halfway between each of those. And luckily, this little graph already has nice markings for us, but otherwise, that's how you'd create it. Okay, and now it says go ahead and graph in a dashed sine or cosine wave, in this case, sine. And if you remember from our day at the beach, sine begins in the sand. Then you head up to the cliff at our next marking. Then we go back to the sand, underwater, and back to sand. Okay, and then we're going to draw this in with a dashed sine wave. Okay, so it should look something like that so far. Again, I'm using dashed in green because this is not my final graph yet. Okay, what we need to do is find, is there a phase shift? And whether or not there's a C value will tell me if there's a phase shift, and there is a phase shift. And to calculate it, we need to do the opposite of C, so the opposite of pi over 2 divided by B, which is 2. Now, this does look pretty complicated here, but when you're dividing by a fraction, and you can just make this 2 over 1, it's the same as multiplying by the reciprocal. Dividing by 2 is the same as multiplying by 1/2. Multiplying top times top and bottom by times bottom, we get pi over 4. And because it's negative, we are going left. Pi over 4 units. Well, let's see. If this is pi over 2, this must be pi over 4, right? Half of that distance. So, in other words, we need to move everything 1 box on this scale is pi over 4. So we need to move everything 1 box left. So this first point, we'd move 1 box to the left. The one up here, we'd move 1 to the left. This guy moves 1 to the left, etc. So these 5 points would now look like this. And I can kind of just use the pattern on my graph to fill in everything else here. I know basically essentially every box we go through back up to the cliff, sand, underwater, sand, cliff, right? We could fill this in, and And again, of course, show this is starting to come back down. And then you could fill in on the left as well. Okay, and there would be my final graph in blue. Okay, our period is pi units. That's how long it would take to complete one sine cycle here, which would actually go from here to here. Okay, but it's been shifted left, right? Pi over 4 units. So to the left, pi over 4, which happened to be 1 box on our current scale. All right, here's example 2. Let's graph the opposite of cosine of 2x minus pi. So again, let's first identify a, b, c, and k. Okay, so a is -1, b is 2, c is negative pi, and k is 0. So identify your vertical shift, which is 0, and you'd mark that as the center of your graph. So in this case, we don't need to go up or down. The x-axis is the center of my graph. Our amplitude, the absolute value of a, is 1 unit. So just like before, we're going to go up and down 1 unit to kind of give ourselves a maximum and minimum value to stay between. Okay, so we've got those marked in. Next, we need to find our period. So the formula, since it's not on the page here, for the period is the normal period, 2 pi, divided by the absolute value of b. So 2 pi over the absolute value of 2, again, is going to simplify to pi. So in this case, it simplifies to pi. It's going to repeat itself every pi units. So from our steps in the previous slide here, I guess if you want to remember, once we find the period, we're going to mark the beginning and end of one period. So we're going to go from 0 to pi. That's the beginning and end of one period. And we need 5 equally spaced points. So what we would do is we'd go halfway, put a marking, and halfway between each of those. And these are kind of the 5 different stages of our cosine wave, right? Which starts on the cliff, heads to the sand, etc. Okay, before we start graphing this in, let's go ahead and find our phase shift. The phase shift is the opposite of c over b. So the opposite of c would be positive pi over b, which is 2. So we end up with positive pi halves. And because it's positive, we are going right. Pi over 2 units. So let's start with our normal cosine waves. Remember, day at the beach cosine starts at the cliff, our highest point. Then we head to the sand, underwater, sand, and then cliff. And that would be 1 full cycle of cosine. Remember to make this nice, smooth, curvy graph, not a V shape. Okay, so that would be 1 cycle of cosine. If we didn't have a phase shift, I could just continue that pattern. But we need to shift this whole graph right, pi over 2. So I look at our scale. This is pi over 2, so it looks like every 2 boxes would be pi over 2 units. So because we're shifting right, pi over 2, this point needs to go right, 1, 2, land over here. So that top point lands over here. This moves, ends up going on top of that point, and we go right 2. This going right 2 ends up here. Then one that was here going right 2 ends up here, and this ends up here. And so here's my graph that's been shifted right, pi over 2. And so again, if I curve this in, we can use that, and we can now use that essentially every box gives us another stage of our cosine graph. So kind of sand, underwater, sand, fill the rest of this in, and graph in the rest of our graph. And there we go. In blue would be our final graph. Okay, let's look at another example. Cosine of negative x, plus pi over 4 plus 2. And what this negative does in here is actually going to give us a horizontal reflection, kind of like a reflection over the y-axis. If there wasn't a phase shift, it would be directly done. And in fact, by figuring out the period and phase shift and graphing them in the way we are, we will kind of perform the reflection already. So it'll be done in the way we graph it. Okay, so let's go through our steps again. Identify A, B, C, and K. Okay, so A is the 1 hiding in front of cosine here. B is the -1 in front of x. C is positive pi fourths, and K is positive 2. So this time we do have a vertical shift. We need to shift up 2 for our positive 2 here. So we're going to mark that like it's our new x-axis. Okay, so there's my marking at positive 2. That's essentially my new x-axis. Next, we'll find our amplitude, the absolute value of A, which is 1. So we're only going to be going up 1 and down 1 from the center here. So we'll put in our markings once again in green. Okay, up 1 and down 1 at most there, to kind of stay between the lines. And then next we'll find our period, 2 pi over the absolute value of b, where b in this case is -1. So remember, we're doing the absolute value, which makes that +1, which gives us 2 pi. So there is no period change, but that -1 will give us a horizontal reflection. So that's a new one for us. So we're going to mark between 0 and 2 pi. We need 5 equally spaced points. So we'd go halfway, which is where pi is, and halfway between each of those. So each of these is kind of a different step in our cosine graph here, since we're graphing cosine. Lastly, let's find our phase shift before we begin graphing. So that's the opposite of c over b, which is -pi/4 divided by 2. Remember again, we said when you're dividing by 2, you can think of that as multiplying by the reciprocal or multiplying by 1/2, which is -pi/8. Ooh, kind of an ugly shift this time. That's going to put us at like half of a box, but we'll see. I think we can deal with it. Let's first start by graphing our cosine wave. So remember, cosine starts at the cliff, so our maximum here. Then it goes to the sand in our next marking, underwater, back to the sand, and back to the cliff. So there would be one cosine wave. Okay, however, we have to shift everything, in this case, left pi/8 units. So if pi/4 is 1 box, which we used in a previous slide, pi/8 would be half of a box. So we need to move everything left half of a box. That is equal to pi/8 units. So pretty short movement for all of these left half of a box. And then we can try to follow that pattern where it looks like essentially every 2 boxes to the left. So if I go 1, 2, this would be the next stage here. And then 1, 2 would be at the bottom, 1, 2 here in the middle, and then slightly off the graph, we'd be back up at the top. Okay, so my final graph would look something like that. Okay, so there's 2 more examples. You pick and choose which examples you want to write down when you come back and watch the video again. It's up to you. So hopefully these are, the explanations hopefully make them make more sense. Okay, so let's go through this one again. Find A, B, C, and okay, and in this case there is no vertical shift, so we don't need to mark a new center. But my amplitude is the absolute value of 2, or 2, so we can go up or down 2 units at maximum. Okay, so there's my markings, up and down 2 units from the center. Our period is 2 pi divided by the absolute value of b. Well, b in this case is 4. Of course, the absolute value of 4 is 4, and this simplifies to pi/2. So it's going to repeat itself every pi/2 units. Okay, so what that means is we would mark between 0 and pi/2. We need 5 equally spaced points. So we'd go halfway, and halfway between each of those. So this is going to repeat itself a lot, like 1 full time within 2 boxes, essentially, for our sine wave here. Okay, lastly, our phase shift, the opposite of c over b. It's -3 pi/2 divided by 4. And again, you can think of that as multiplying by the reciprocal, or dividing by 4 is multiplying by 1/4. So we get -3 pi/8. Ooh, this could be a tough shift. Wow, we'll see if we can deal with that. But I think, remember, if 1 box is a pi/4 on this scale, that half box is a pi/8. So we just need to go left 3 half boxes, 3 pi/8. So we'll deal with that. Okay, so first let's graph in our sine wave in this little tiny spot where we go very, very high. So we start from 0. In green, from 0. At our next stage, we're at the highest point, the cliff, right? Sand to cliff, back to sand, to underwater, and then back to sand. So man, very, very steep sine wave here with that amplitude change and period change. Okay, so that would be 1 sine wave, but now we need to do our phase shift. And we need to move everything left 3 pi/8. So this is 1 pi/8, 2 pi/8, 3 pi/8. So 3 half boxes, 1, 2, 3. That's where that point would go. This goes left 1, 2, 3 half boxes. This guy goes left 1, 2, 3 half boxes. And this goes left. 1, 2, 3 half boxes. And I almost forgot about this guy. Goes left. 1, 2, 3 half boxes. So far, my very steep sine wave looks like this. And we can continue that pattern. Basically, every half of a box would continue our pattern of sine. So if you want, you can fill out the whole window. I'll do that. You don't necessarily need to. Okay, so our final graph would look something like that. Let's move on to the last example. Okay, graphing -3 sine of x minus 3 pi fourths plus 1. Let's see what we can do here. So identify A, B, C, and K. Okay, our vertical shift is +1. So we can go up 1 and make that our new x-axis. And our amplitude is the absolute value of -3 or 3. So we'd want to mark from that new x-axis that we can go up 3 and down 3 as our maximum and minimum. Okay, so there's our max and minimums values marked. Let's find our period, 2 pi over the absolute value of b, which is going to be 2 pi over the absolute value of 1, which of course is going to simplify into 2 pi. So there's no period change. So we're going to mark between 0 and 2 pi and get our 5 equally spaced points. So halfway, which is at pi, and halfway between each of those. Those are our 5 equally spaced points for our 3 kind of different stages of sine, like cliff, sand, underwater, etc. So for sine, remember sine would start in the sand. Ooh, before we do that, let's do our phase shift. Opposite of c over b. So opposite of -3 pi fourths would be +3 pi fourths over b, which is 1. So dividing by 1, it's just 3 pi fourths. And since it's positive, we are shifting right 3 pi fourths. Okay, let's go ahead and graph in our different parts of sine here. Now, sine, of course, normally goes from the sand to the cliff, again, at our next marking. Back to the sand at our next marking, underwater, and sand. However, this time my amplitude is negative, right? Which means we have an upside down graph. Which means I did make a mistake on a previous slide, and some of you may be screaming at me. We're going to go back and fix it as well. So in this case, remember, this has been flipped upside down. So my graph, rather than going up to the cliff, is actually going to go underwater. So it's going to go this way. So we have that reflection. Instead of this point being underwater, we're up here at the cliff. Instead, this is a reflection of a sine wave, right? Because our A value was negative. So here's the reflection of our sine wave with a period of 2 pi. Okay, so don't forget that. We missed one on one of the previous examples. We'll fix that in a second. Let's first shift this left 3 pi fourths units. So we've concluded that between pi over 2 and 0, this is pi fourths, and we need to go 3 pi fourths to the right. So that's 1, 2, 3 pi fourths. So in other words, we need to move all these points right 3 boxes. So this guy going right, 1, 2, 3. This one going right goes 1, 2, 3. This one going right goes 1, 2, 3, etc. And then some of these obviously are going to go out of our window a little bit. So that's fine. We will just continue this pattern that was happening on the left in green. Essentially every 2 boxes, right, would take us to the cliff, left 2 to the sand, left 2 underwater, back here, and then move all of those to the right 3 boxes as well. So 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. Or every 2 boxes, just continue the pattern in blue, whichever method you prefer there. And now we can graph in blue our final graph, which has the correct reflection here. Okay, so there's our final graph on number 5. Let's go back and make the correction here, which was here on example 2, right? I forgot that we had a negative value as I was speeding through this video. Let's correct this. I will use black. Essentially, we just need to take our graph in blue and reflect it, right? Which means points that were on the cliff are now underwater and vice versa. And everything right on the center will stay the same. So we'd reflect all of these points in blue over. And we should get a graph. The correct final graph should look something like, okay, in black. So you can ignore the one in blue there. Of course, we didn't do the reflection in the end, right? I probably should have done that on my dashed green graph. done the reflection, and then moved those points left and right. So if you do have a reflection, a vertical reflection, do that when you're doing kind of your dashed green 1 cycle. Go ahead and perform your reflection then, and then shift everything left and right and fill in your